Hi guys, this is Shrish, and today I'm here with experiment number 6 in System Software and Compiler Lab. The name of the experiment is Single Pass Assembler for SIC. So now let's get on to the experiment. As you can see over here, the aim of the experiment, that is the objective of the experiment, is to convert the assembly language program into an executable program. So let's get on to my program. Yeah. So first we are gonna take in files such as assembler, op table, symbol table, in which where you have opcode and everything. I'll show you. See, in assembler you have the assembly level code, assembler code. In table you have opcode for particular operations, that is SDA, LDA, which will be used, and in symbol table you have the values for the variables used, that is alpha, beta, gamma. You can see it over here, alpha, beta, gamma. That's a variable, it holds the variable, the symbol table. um, so we are reading it and storing it in FR and FR2, FR3, um, etc. And we are also creating file writers from FW, and FW3 for all these files, because we'll be reading the files now. We're reading assembler, opcode, intermediate, and symbol table, and we'll be writing in intermediate, symbol table, and output table, output.txt. So now let's get on to the program. As you can see over here, if the line contains start, then you'll have this while loop running, and it will check if I is less than word length. So if I over here is initialized as 0, so obviously in this situation it will be running, and when I increments over the word length, then it will stop running. So if I is equal to start, then n is equal to I, and you have a break. So I gets incremented over here. So if word dot length is less than n, that is the thing over here. So what happens over here is word variable, that I mean the word which comes in that gets stored in as what is integer in LC, and LC is printed. Otherwise, LC is equal to 0 and start is equal to the value of LC. Then you'll read the line, and you'll make a new line. That's it. Else, that is, if you don't, if it is not a start thing, so if it is in middle or something, and I is equal to 0, j is equal to 0, again the same thing, it checks for line word length. If it is less than word length, then it will go for this octave, it will go for the words that are given in the octave, and it will see if the words in the word, that is this array, is equal to the words that is given in octable. If it is equal, then it will get converted to the corresponding value, as you saw over there. See, octable. If there is a match for ST, then it will be converted into 23 and stuff like that. Yeah. So now this is the spacing, because um, you yeah, this is for splitting. Then we'll be printing the opcode plus word and opcode plus word. Then LC is equal to LC plus 3. So suppose if the line contains word, byte, reserve byte, then you'll have this following, that is LC is equal to LC plus 3, because it occupies 3 spaces, byte occupies 1 space, and over here B2, so it gets copied, as you can see over here. Yeah, it gets copied to buffer write 2. Yeah, buffer right too. Then the word along with the LC value and new line. LC is equal to LC plus percent word to 2 plus 3. So you'll get the new value of LC. Um, then for byte is just this part because it's just one byte. So the reservation along with byte is just LC is equal to LC plus percent word 2. Now let's see over here. So what we are doing here is we are creating a string array called word, and we're going to take the splits. Then we are going to print out the word twos, that is word 2. Then we're going to check symbol table dot split. If there's a split, then it gets copied over here. Words get splitted and each of the words gets copied over here. And as you can see over here, if symbol j dot equal to word dot 2, then symbol is equal to sym j plus 1. So symbol j contains all those things. So if it is equal, then whatever word comes next to it gets copied into symbol. And line is equal to line dot replace all word with symbol. So what happens is for the particular word, instead of the particular word, this particular symbol, that is the next digit, will be copied in. And over here if you see is a split thing, and we have to start writing it with a h because the h contains the header word. So word 0 contains the heading, verse 2 contains the starting address, and length contains the total length of the thing. Or else if it's just other lines, then it should start with T, then it should proceed with 00, and you have the verse that is, you can say, starting address and then 03, then whatever word that comes after that, then when it ends you have to type exit, then you have to type start. So this brings to the end of the program. Now let's just run it. First let's just check. Yeah, assembler contains this, as I showed you. Intermediate contains nothing. Yeah, because we have to derive it. Output also contains nothing. Balance everything, symbol table is filled and op table is filled. Now we are gonna convert this assembly level language to an executable language. So let's run the program. As you can see, build is successful. Now let's go to that. If you see over here intermediate, you have the intermediate code generation, and if you see the output is it's a perfect executable code. So this brings us to the end of experiment number 6. Thank you for watching.